So, as Kaustubh and Justine have been mentioned, that looking for signs and looking for the animals themselves, that is one way to go about the occupancy surveys, and that has been one of the most dominant ways in which occupancy has been conducted for most species. However, we get into certain situations when we have certain factors to keep in mind. For example, we might be requiring to cover a huge area within a very limited time frame to understand the distribution of a particular species, and that species might be uh, either naturally occurring at very low densities. It might be very difficult to see them using even, say, spotting scopes and binoculars in general. And we would basically have a very hard time in detecting or documenting presence of that species in a particular area of interest. And that's where the alternate idea of using interview surveys came into being. And as I have been mentioning, that why interview? So I've already started with that. So, for example, we might have an area of, say, about 15,000 square kilometers, as you can see on this map. So this is one particular area in northern India, the state of Himachal Pradesh, where we have about say 26,000 odd square kilometers as the
Abhishek, can you put the mic near your
Sure.
voice? Thanks. Sorry, we sometimes lose you. Great, thanks.
Sure. Yeah. So we might have a huge area like this. The gray shaded area is the potential habitat of snow leopard in the Himachal Pradesh state, and it covers about 26,000 square kilometers, and it's just not logistically and economically possible to cover this much of area by physical surveys, be it sign surveys, be it camera trapping, be it genetic sampling. It's just not feasible to cover this entire area. And as I mentioned, that there might be species like the snow leopard, which are extremely difficult to be seen in the first place. And even putting camera traps across such vast area or conducting genetic sampling across such vast area might be logistically and economically not feasible. And that's when we came up with this idea that we can use individual uh, persons living in those areas, spending a lot of time in those areas on a daily basis, and if not on a daily basis every day in the year, but at least say 5, 6 months of the year, people are spending a considerable amount of time in the snow leopard habitat, which are essentially areas about 3,000 meters in case of majority of the Indian snow leopard habitat. And so the first and foremost thing that we did and we believe is of utmost importance is to understand the area even before we go into the field, even before we start thinking about the interviews. So what we did was basically we had this entire area in mind that we wanted to assess distribution of smaller birds and prey species for. And then we zoomed in individual values. So if I again go back to this particular uh, slide, and I'll just try to use the laser here. I hope all of you can see this red dot. So we have major river valleys. So for example, this is one major river valley. This is another major river valley. This is the third river valley of this region, fourth one, fifth one, and so on. And there were like 50 plus river valleys stretching from the easternmost part of the study area to the westernmost part. And uh, again, as I said, the sheer scale of the area that we were interested in made us go into each of these areas virtually first. And this is basically one of the valleys from this area that we have used. So this is one valley. This is one of the villages in that valley named Hangi. And this is the river going upstream, and the green shaded area are the areas above 3,000 meters, which are potential swampy habitat. And so the first step that we used was to get an understanding of what this area looks like. We looked at Google Earth maps. We looked at any literature that was existing about this particular area. And we developed these very simple figures or maps with which we could get ourselves familiarized with one particular value. And then we started thinking about how we can basically get to the interview. So we had to prepare ourselves for a lot of listening. And what we did initially, once we were in one of these villages as say, Pangi, we went there, we spent a couple of days walking into the valleys, looking into the valleys. We came back, we interacted with local people there. It was nothing formal. So we would sit in a, say, a tea stall or a small eatery in the village where usually people gather. And we try to understand how the valley is laid out, what species occur in that area, what are the conservation issues or peculiarities that might be there, what sort of developmental activities are going on, where are the agricultural fields, and we used these sort of photo plays for the species identification, the details about which I'll get into the presentation. We use these photo plates to understand how many of these species are identified by the local people. And we could sort of realize that it's probably much easier for the people to, you know, identify a species when you only give them species of that area. So we mixed it up. We used certain species that are not found in the Himalayas, for example, the nilgai. Same for the carnivores. We used, say, fox species that is not found in that area, while we used common leopard, which is not found in majority parts of the high altitude Himalayas. And we try to understand what are the capacities of the people in identifying species, since we would not have a first-hand experience of observing those species with them. And so we basically, based on the overall discussion with a focus group sort of thing, where we would typically identify, say, 2 to 5 people and document these basic characteristics of a valley and an area to begin with. We went ahead with finding out more details about the valley. So we basically had, say, for example, the stuff on black font we had initially before we went in there. But then, based on our discussion with the local people there, we could identify some of the more uh, unknown or poorly known terminologies or names of the local names of the valleys and pastures inside that larger area. And this basically helped us get familiarized with the area much better. And we had more confidence in ourselves when people started reporting that they had seen some particular species here, or they had seen, say, ibex in one of the pastures, but blue sheep in some other pasture. So we could relate. And that's really important. So that is why I emphasize that even before we, and it applies to even, say, science surveys or camera tracking surveys, that we really have a very good understanding of the interiors of the valley or the particular area that we are going to survey beforehand. It's sort of having a virtual reality map of that particular area in your mind, even before you step into that area. So we basically kept on populating the initial map that we had created based on our interaction with the local people. And out of those people whom we engaged with for the focus group discussion, we would identify, say, 2 and more people to represent detection, non-detection data from that particular value. So we would identify people who had been really spending a lot of time in the snow leopard habitat, who seemed to be knowing a lot about wildlife in general of that area, keeping an interest in biodiversity matters or knowing about the natural history of the species and the area. And then we got into individually interviewing them because, again, as Kaustubh and Justin also mentioned during the mock session that you guys had earlier, that independence of data is of utmost importance. And that is why during the focus group discussion, we did not ask them about species detection or non-detection, but during the individual interviews, we got into the individual detections or non-detection information collection part. And there, then what we did, if you can see these colored dots in the map, for example, the green dots are where so people had seen snow leopards during 2011-12. During 2012, we were doing these surveys. So over the last year, where they had seen snow leopards are in green. The pink dots or the purple dots are where people saw ibex, and the blue dots are where people cited blue sheep or bara in this particular valley. And now, what the next? So we had a series of sort of tests to understand the reliability of the data. So, as I mentioned earlier, we used photo plates, and if someone could not identify correctly the focus species, then we did not go ahead with that interview. We dropped that particular respondent. We, of course, continued with the discussion, maybe, but we did not consider that particular respondent as a data point or a respondent per se. But there were people who did identify snow leopards and the prey species correctly, and we moved ahead with that person. And we had a series of other questions as well. For example, if they could identify the signs of a particular species, if they could sort of understand the calls of different species, if they could correctly mention where usually one could see the focus species within a larger valley or the area of interest that they have. And that's how basically we screened the respondents to begin with. And only then we went ahead and documented the detection data from them. And in this way, basically for each and every valley, we documented where all within a particular valley the people saw or did not see snow leopards and the prey species. And overall, once we completed the entire exercise from the southeastern corner to the northwestern corner, we had this sort of simple map showing the locations of the detections. And again, understanding the interiors of these individual valleys or the grids is extremely important because one needs to know where to put these points. It is fine if we are sort of deviating, say, 10 meters or 50 meters, or even I would say 100 meters from the exact location. But as long as they are sort of within the same valley or the ultimate sampling unit, which might be a grid that you might be using, it's absolutely fine. The exact location doesn't matter as long as it is within the sampling unit. So this is the overall sort of information on detection of the species that we could gather based on nearly, if I remember correctly, 400 interviews that we conducted, and out of which we had to drop nearly 40 or 50 of them. So nearly 10% of the respondents had to be ignored or dropped because we found those respondents to be unreliable in terms of the quality of data that they were reporting. And then what we did, we sort of used this detection non-detection data, and we put it in a detection non-detection matrix, which I'm sure Kosov or Justine will show you at a later stage, or even I might show you just after I'm done with this, how the data sheet looks. And we analyzed the data in a multi-season. So we were interested in understanding how snow leopards and prey species distribution have been changing over a period of 30 odd years. There were certain activities or certain things that had happened during the early 90s. So we had a sampling session or a sampling season named PAST, which was from 1985 to 1992. So we recorded the detection non-detection of these species from the respondents for that particular time period. And we recorded the detection non-detection for a more recent time period, which was 2008 to 2012. So 5 years for the recent time period season. and 7 years for the past time periods. And we used a multi-season single species occupancy modeling. And this is what sort of the small leopard occupancy looked like. So again, as Kaustav mentioned during his speech earlier, occupancy values range from 0 to 1. So the lighter shaded grids had lower probabilities of occurrence of snow leopards versus the darker ones and the very dark ones, like the complete black ones, which had nearly 100% probability of snow leopards being using those areas. And similarly, so this was for the past time period, 1995 to 1992. And this was for the current time period, 2008 to 2000. And we had a slight change in the occupancy value. It was, I think, about 15% reduction in the occupancy value, overall occupancy value for this entire period. And using similar principles, we developed occupancy maps for the prey species. So the row above is of the blue sheep, mainly restricted to the eastern part of the study area. And the lower row is for the ibex, past and current for both the species. And using this sort of an approach, interview-based approach, you get a lot of additional information like the conservation issues that are prevalent in that particular area. And as we all understand that it is not possible for one researcher or even a team of researchers, even say spending 1, 2, or 3 seasons in a particular area, especially if an area is as large as this, we cannot get a complete understanding of what all are going on in that particular area. And that is why we think that talking to local people through formal ways and using tools with which we can ultimately use the information that we are collecting to analyze them and get robust understanding of the threats. So we used an existing threat ranking analysis based on a previous publication by Margolui and Salafsky 2001. And we came up with a list of threats, and then we could prioritize them based on area intensity and urgency. And we realized that there were these 3 major threats that existed in this particular region. And again, based on interviews, we could get rough estimates of the intensity of some of these threats. And it basically represents livestock grazing, migratory livestock grazing in the area, the existence of roads, and the sort of intensity at which disturbance might be there along those roads, and some of the major hydropower projects that are spread across the potential snow leopard habitat in this region. So I want to emphasize that this sort of exercise, although we are not very used to, we are definitely much more used to the conventional and field-based approach of collecting data based on science or direct sightings, but we did use this alternate method of using the knowledge, local knowledge of the people living in the snow leopard habitats, using the number of respondents as the number of replicates, representing those sampling units. And we ultimately published this work in Oryx in 2017. And it basically allowed us to understand what has been going on regarding the distribution of one of the most elusive species in the animal kingdom, along with its prey base, over a period of not just a few months or years, but over a period of, say, 30 years in our case. And we believe that it is a very powerful tool when used in a robust manner, when designed in a very robust manner, and then, of course, analyzed using the right tools, keeping in mind the limitations. And we have to be absolutely sure that we are not overstretching the findings, we are not overemphasizing the, particularly, say, like Costa right now mentioned about the covariates, and I'm sure the details will come in the next session. So all we ended up doing is to have an understanding of the distribution and understanding on some of the factors out of many factors that might be operating, on how those might be influencing the overall pattern of occurrences of smaller birds and prey species at this large scale. So I would like to finish here, and we would probably have questions or discussion on this. Thanks a lot.
Thank you so much, Abhishek. It's really great to see a real life practice of this, and also trying to keep the data rigorous, I think, and avoid false positives. I do, as we get questions coming in, Kustub, can I ask quickly one question I am very curious about? Abhishek, how did you might have said it, but sometimes the sound was a bit hard, so I'm gonna ask, how did you denote when there was no detections? Because I saw on the map you were noting detections. So how did you define no detections? Because we also need information on that, right?
Right. So what we did was that when we started talking with a particular respondent, we mapped out the area from which this particular person was reporting. So one person, even if it is say one valley, one particular herder or one particular lady who usually goes out to collect say dung or fuel wood, that person would not be reporting about the entire region. So they would have certain pastures or certain ridge lines within that particular valley with which they are more, they are more aware of, and they were reporting from that area. And we would, and it again, as I mentioned, that if we put in enough effort, then over a period of say 10 years, we were asking to begin with where all did they see smaller birds and prey species. And the next step was to ask, okay, pinpoint at least a few locations where you have never seen. So those were our non-detection locations. And again, we need not have the absolute pinpoint location. As long as it is within the larger sampling unit, you are doing absolutely fine. And of course, so this is one part of the non-detection from one respondent's area of knowledge. And there's another way of documenting non-detection, which we had also done was, for example, for one particular valley or grid, you are interviewing, say, 10 people. So out of the 10 people, 6 might have seen smaller birds. So we would have multiple detections for them. And say 4 of them may not have seen smaller birds from that region. So again, the same thing. So we would ask, okay, so where all have you been visiting within this particular valley? And so those valleys automatically becomes their non-detection location because they have never seen a smaller bird or prey species in those areas.
Great, thank you. Yeah, thank you. It was a great, really interesting talk. Thank you for sharing all the insights, the behind story to that paper. I've read that paper many times. I think it's inspired many people across the range to replicate that method. Are there any questions from the audience for Abhishek? It's a unique opportunity to directly ask him any questions you may have. Or Kustub, I don't know if you have any other thoughts.
No, I mean, thanks, Abhishek. That was very helpful, and that, I mean, even though I think it's we've done similar analysis on 2 or 3 locations, it's always a mind bender. And hopefully next session we'll also have Muzaffar, who's used your methods, Abhishek, to explore snow leopard distribution along with leopard and bear in entirely a new area, and he's had some interesting observations as well. So hopefully we'll have him talk a little bit next time. But yeah, but it's very useful to go through what you went through the whole process and review the key do's and don'ts. Thanks so much for sharing those. So I have a couple of questions that people have asked in the meanwhile.
Can I ask one more question to Abhishek? Sorry. Just before, and then we can go to the other wider question. I wanted to ask, did you define your grid cell size before going out? Or did you define that after based on detections and non-detections?
Right. So we did define the grid cells size based on the smaller bird home range size, which was reported to be 2,207 square kilometers mean for an adult male snowleopard. And so our grid size was fixed to be 15 kilometers by 15 kilometers. However, while implementing the surveys on the ground, we did not account for the grids there because for interviewees, it's not possible to comprehend where a grid starts and where a grid ends. And also for us, whom when we were conducting the interview, it's just not possible to keep in mind, okay, this is where my square grid is ending and that is where another grid is starting. So we completely focused on basically maximizing the coverage of the area and maximizing the detection, non-detection from the respondents. And as Kaustubh mentioned that we did have multiple, so if I can just for half a minute, maybe share the screen, is that okay?
Yep, please.
Okay, so I'll just quickly show one of the data sheets that we had developed. So, for example, these were our 88 grids on the leftmost column, and these were the number of respondents from the entire survey. So we had, I think, a total of say 27 respondents, maximum of 27 respondents reporting for one grid overall. Once we overlaid the detection on detection data on the grid, sorry, rather the other way around, when we overlaid the grids on the detection on detection data. And here, as you can see that there were grids where nobody had seen a snowleopard. There are grids where people, some of them did not see and some of them did see a snowleopard. And we also had grids where we did not have any replicate. So this again brings in the very important point that Kaustav was making earlier that NA or not applicable or not getting a survey done in a particular site is equally important as getting surveys done and not getting any data, the zeros. And similarly equally important are the sites from where we do get multiple replicates and we have a combination of detection versus non-detection.
Thanks so much. That's a great example, Tashi. And we're going to go back to an example like this next week. So yeah, we'll build on that. Thanks, Abhishek. Kaustubh, over to you. Yeah, over to you.
Thank you. And sorry, everyone, for going over time. But I think if you've been with us, you know that this is typical of us. Sorry. Even though we would like to stick to time, yeah, we do end up. I think it's the excitement of working with you all. So there are two key questions, and I think very good conversations and very good discussions. So one of them, I think, Chloe, you mentioned, which is a very good point, that relationships are not always linear. I think Helena or someone else also mentioned that, or Nilofer, you mentioned that as well, which is so true. What you do, you all only give the answer, generalized additive models. Some people call them polynomial models. And to be more specific, you can go with quadratic models, which are polynomials to the second order, or sometimes you can go up to 3, 4, or 5 polynomials like spleens, as they call them. These are all doable. But the only thing we need to be very careful about is that the more parameters you add, the more the model will fit, but the less generalized it will become. In other words, there's a cost that you pay for every new parameter that you add. So while the fit gets better, you get penalized, or you're penalizing, or you're basically penalizing the model by adding a new parameter, losing the generality of it. And that's why we always strongly recommend that we use AIC, Akaike Information Criteria. What Akaike Information Criteria does is it kind of balances out the gains from adding a parameter versus the cost of adding another parameter. So the gains in improving the likelihood or improving the fit versus the penalty of adding another parameter. And it does a fairly good job of doing that, which is why it's much more important, if you're using additive models, to test them against a lot of simpler models as well. Sometimes you might think there is a the relationship is not linear, and most of the times it isn't, but how much of that of the cost of that linearity you can let go for a gain is very important. And we will do one simple analytical exercise. I'll share some codes with you, and you will see how it becomes very valuable to test the additive model with the straightforward linear model and see how the responses vary. There was another point that sometimes site covariates can also affect survey covariates. If you remember last time, Justine had made a very good point that it's not a good practice. What happens is, because you're using a maximum likelihood based approach, the likelihood estimator gets confused, and it might overweigh or it might provide spurious relationships when they may not exist. Look at it carefully. Your detection is happening at an entirely different scale than the species is using the landscape. You're detecting it most of the times at a smaller scale, few meters, few hundred meters, right? Or at a, if it's a camera trap, it's just the area right next to the camera trap. The field of view is where it's detecting or not detecting. But the species is not using at the same scale because our sites are much bigger. So it's a very important point to I think it's a rule of thumb. Don't use the same covariate as a site and a survey covariate. Both, if you want to use it in one, then don't use it in the other. Because if you do that, there is a very strong chance that, at least that's what we understand, that the modeling, the likelihood estimator gets confused, and it doesn't really provide a very reliable estimate. Am I right, Justine? Is that exactly what Daryl had explained?
Yeah, I mean, he said it's especially the case for models like Maxent, where you can't differentiate from detection.
Oh yes, of course.
But it's less of an issue for occupancy, but he still would like people to just be mindful that it could affect the model. But maybe also he recommends, and we also recommend, that we should avoid going on a fishing exercise and just testing all covariates that might be possible. Just because there are site covariates testing on detection, you have a hypothesis behind it, right? Because we often have little data, and we don't want to be testing everything. We want to be very much more strategic and have a reasoning behind it. So yeah, and that goes back to what Kustup just said, AIC. Right?
The two more, yes, absolutely, Justine. Thanks so much. The two more points, and both very good points. I mean, this is a wonderful group. It's just such a pleasure working with you here. One of them is for time effect. I'm not sure how bad it affects occupancy modeling, but in MR, which I assume is mark recapture, we made sure to not have that because we already had heterogeneity and behavioral effects. Yes and no. So let's go back to mark recapture. In mark recapture, if you are using a behavioral effect, it's a subset of time effect. In fact, it's slightly different because a behavioral effect would indicate that if an animal is captured once, it will never get captured again. Or the converse of it, if the animal is captured once, it'll keep getting captured every time after that. So it changes the detection probability once detection happens, right? Whether either it improves or it reduces. So one of the two things might happen. So that's one point. If you're just using the conventional capture recapture, it'll be a good idea to test it. And there are means to compare models using AIC there as well. So that's one point. As far as occupancy is concerned, it totally depends on what's happening. Now, if you're doing a survey starting in summer and ending in the rainy season, there is a likelihood that there could have been a time effect on your detectability, right? So you might want to test it. But again, which effect you want to test should come from your and the field team's observations rather than a statistician sitting somewhere completely unrelated saying that, oh, everyone has used these parameters, you also test that. Everybody, all the analysts who we've had the good fortune of working with, strongly recommend against it. That's what Justine Justine just mentioned as data fishing. Don't do that. You will have enough information about what might be happening and use that information to be able to inform the creation of what they call as candidate set of candidate set, where you decide, okay, these are the relationships I'm going to test, and then you test those relationships. Then there is one more point. Okay, there is one point here from Nilofer. When it comes to a relatively long period of time, I always wonder how we can address the probable biases. For instance, how we can trust people's memory. Does the replication, ask more people, cover the issue as per each grid? Okay, very good point, Nilofer. There are, again, several elements to it. So the way Abhishek tested it was very interesting. In Abhishek's work, Abhishek, sorry, I'm just speaking on your behalf. It's a bit loud around your background, right? So I'm just taking the luxury here, or the excuse here. So what Abhishek did was Abhishek tested if, so what is it? People recollecting and informing the observer is like detection, right? So what you're saying is that for a past period of time, there is a likelihood that they may not remember very well, but for current time, they might have better memory. Or for the past period, they're talking about 10 years versus current time, they're just talking about 1 year. So again, efforts have also changed. Abhishek did a very simple exercise. He just tested the probability of detection to be a function of current period and past period. Was it different or not? So he tested if it was different. And the model said it was not different in Abhishek's case, but very interestingly, 3 other analyses we've gone through, including one very recent one, which has just been submitted. There was a very strong effect of time period. So in some cases, it may have an effect. In some cases, it may not. You have the luxury and the tools with you to test those. Is it an effect? Use a time variable model. And the time variable model are very easy to program either on R presence or conventional presence. And you test it, whether the period had an effect or not. Past period, current period, did it have an effect? It will tell you if it was significant enough, then the AIC will be low enough for the model to rank up. If it didn't matter, it will just say you're adding a parameter, but it's not giving us any benefits. And then it'll just complain, saying that you don't need to add this extra parameter. So that's how you can decide. And again, the question that you pose, you have an analytical mechanism, means here in your hands to be able to test it. And that's exactly one big benefit that occupancy methods have over other methods such as even Maxent, that these methods allow you to compare various hypotheses and models and balance the gain versus the cost of it using AIC. So that's where it becomes very useful. Justine, any more?
So just to add to that point, if I may just add to that point.
Of course.
And if, for example, there is a very clear effect of season, or say the data is saying that there is indeed a time related detection issue, then the surveyors, in case of direct field survey method, or say, for example, the respondents in case of an interview-based method, can be categorized further. And that can be used as an additional survey covariate if it justifies addition of another covariate, and can be modeled just like any other covariate in the modeling framework. So yes, so I just wanted to mention this additional point, that if we indeed see that time or the seasonality indeed it has an impact, then there are additional ways in which one can account for that.
Fantastic, great, cool.
Great.
Yes, Chloe, it's a fairly good. Sorry, Justin. Go ahead.
Go for it. Finish, Gustav.
No, I mean, Chloe, good point. Again, the only point I would like to make here is to be wary of confounding effects, right? Because the estimator doesn't know. It's just going to treat the same. And since everything is being calculated at the same step, you wouldn't really, you might want to be a little careful at the scales at which both are estimated. So that could be one factor. when you're saying you're hearing calls now, I mean, if your site, oh, by the way, that's another important point, and you'll find this example in Daryl's book, that if your calls are possibly coming from from outside or another sampling unit, then you might have a challenge as well, right? So then you might want to increase the size of your sampling unit so that the observer's detection are happening within the sampling unit. If your detection is happening outside the sampling unit, then again, there's a problem there. But again, I'm sure you guys have taken care of those issues. But yes, it's a very good point, and some of those issues that one has to be careful about.